Hey, what's up? I'm Shivam Pandey. This is How to Game Dev, and welcome to the second part on creating a hyper-casual game in Unity. In the first part, we have created our truck script and initialized our scene, and in this part, we'll make our plane move and spawn some deadly missiles coming up.
So let's continue by creating our plane. For that, I'll right click and create an empty game object, rename it as plane. I'll reset its transform first, then add a sprite renderer to it with that aeroplane sprite. Now the scale looks good and I'll position it up a bit. We do not need any colliders in this, but I'm going to add a script, that is the plane src, plane src, and open it upon Visual Studio. So this is the plane script that we have created, and it is much similar to the truck script. I'm going to remove those using tags and this function. I'm also going to remove this comment here. Now we'll start by creating a public float for its speed, then name it as plane speed, and then I'm going to create another boolean value, a private bool, and name it as moving right. Now we'll go to our truck script and copy these two lines of code here. Okay, now we want to check that if the plane is moving right or it's moving left. So if it's moving right, then we should make it move on the right direction, else we should make it move on the left direction. So if it's moving right, I am pasting those two lines of code here. So if it's moving right, then transform.translate vector3.right, and this would be plane speed. Okay, and we'll multiply it by time.delta time. Next, if it's moving in the left direction, then vector3 must be left here. Yes, and this must be plane speed. Okay. Now if you go back to Unity and select the plane game object, you can see that when it is moving on the left direction, then the flip x is false, but when it is moving in the right direction, then flip x must be true. So we need to change this in our script. I'm going to my script, and if it's moving in the right direction, then the flip x must be true. Yes, and if it's moving in the left direction, then flip x must be false here. That's okay. Now we have assigned our plane src to a plane game object, and if I put the plane speed to 10 and hit the play button, you can see that the plane should be moving now. As you can see, the plane is moving, but it has no way of coming back and rebounding like we did it in our truck script. We can do things similar to what we have done in truck, like we can add two coordinators here, and if it is colliding with them, then it should rebound. But as you can see that this screen size may differ many times, and if you are using different devices, or if you are publishing your game into different devices, then it can cause a problem. We need a more generic method for this. For that, what we can do is we can calculate the screen boundaries of the current device in which we are working, and if its transform passes or touches this screen boundary on any of the sides, then it will change its direction. So to calculate the screen boundary, I am going to create a new script, a new C# script, and name it as screen bounds, and open it on Visual Studio. Now this is my screen bound script. So firstly, in the script, I am going to remove this void start function. We don't need this. Nextly, we are going to remove these two using tags. Now we need the reference for our main camera. For that, we'll write camera.main. And now we are going to use a function of the main camera, that is screen to world position or screen to world point. Screen to world point. Now this function accepts a vector3. We are going to create it here, new vector3. And for the x component of this vector, we need the width of our screen, that is screen dot width. The y component of this vector needs to be the height of our screen, that is screen dot height, and the z component must be the z transform of our main camera, that is camera dot main dot transform dot position dot z. So what this function will do, this function will firstly calculate the center position of the screen that is visible to our camera, and from this center position it will return a vector 2. The x component of this vector 2 would be the distance of this center from the left side of the screen, and the y component would be the distance of this center from the top of the screen. So I am creating a vector 2 to store these two things, that is the public vector 2, and I'll name it as screen bounds. Okay, and now I'm going to store this vector 2 into screen bounds. Now screen bounds equals to this whole function. Now this screen bound stores in its x component the distance between the center to the left side of the screen, and in its y component the distance from the center to the top of the screen. If I write now screen bounds.x, then this would be equal to the x position of our left side of the screen, and if I write negative of screen bound.x, then this would be equal to the x position of the right side of the screen. And this is what we are going to need in going to use in our plain src script. So let's go to our plain src script. We'll save this. Now in our plain src script, we need to check that if the transform.position of our plane is equal to or less than the left side of the screen, then it should move in the right direction, and if it's equal to or greater than the right side of the screen, then it should be then the plane should move in the left direction. So we'll check it. If transform.position.x is less than equal to find object of type, firstly we'll catch this script, screen bound script, find object of type screen bounds, and from that we'll catch that vector 2 we have created, screen bounds, and we'll catch its x component. Now this means that if the transform.position or the x position of our plane is less than or equal to the left side, the x component of the left side of our screen, then something would happen, and that something is it will start moving in the right direction. Moving right equals to true. Okay, and if I'm going to copy this, if transform.position.x is greater than and equal to the negative of screen bound.x, that means if its position is equal to this side of the screen, then it will move in the left direction. That means moving right equals to false. That means it will start moving in the left direction. And that's all we need in our script now. Now if I hit back to Unity and I'll go to main camera and assign the screen bound script to our main camera. Now you can see a screen bound vector 2 has been created now, and if I hit play you can see some changes into this vector. So I'm hitting play now. And the game started, and you can see that there some values for x and y component of screen bounds have been assigned, and you can see now the as soon as the transform.position.x component of the plane is hitting this or this side of the screen, then the plane is changing its direction. And since we have used this screen bound in the update function, then you can see that it is updating in real time. So it is a very generic function you can use in your game. If I resize this, then it is working pretty good. Now the plain script is completed, and now we need something to which we can spawn our missiles. So I'll go to plane and right click on it and create empty. This would be the missile spawn component. Is a missile spawn point. Okay, I'm going to the scene, and if I focus on this, I am going to put it a little bit down, yes, like this. It's okay now. And now we need to create another script for our missile to be spawned, and name it as missile spawn script and open it. Now this is the missile spawn script. We are going to remove these two tags, and I'm going to remove the start function. Firstly, I'll start by creating a public game object and name it as missile. Yes. Nextly, I want to instantiate the missile. For that, I'm going to select the instantiate function. We want to instantiate the missile. The position should be the position of the spawn point, and this script is assigned to the spawn point only. So we'll write here transform.position, and the rotation of the missile should be what its identity is. So we will quaternion dot identity. That's it. Now we want that only when we click on the screen the missile should be instantiated. So for that we'll write that if input dot get button down, and the button is fire 1. This is another name for the left click. Get button down fire 1, the missile would instantiate. Now in our game we have seen that if we are clicking on the left side of the screen, then only the missile is instantiating. But now we can define it like this. Later on we can change it to left and right clicks, and we can defer those two clicks. I'm going to save this script now and hit back to Unity. Now I'm going to assign this missile spawn script to the missile spawn point like this, and we need a missile prefab now. So for that I'm going to create a new game object. I'm going to save the scene and create an empty game object, rename it as missile. Yes, reset its transform, add a sprite renderer to this, and for the sprite I need that missile sprite. I'll scale it down a bit to 0.3 and 0.3 in the Y. I'll scale it up to 0.5 and 0.4 in the Y, or 0.4 in the X and 0.4 in the Y, and that's okay I guess. And I'll rename it as missile. I'll add a box collider to this, and box collider 2D, go back to our scene, and I'll adjust the collider, adjust it a bit like this. I'll firstly focus on our game object and adjust it like this. I have renamed it as missile. Yes, and I have added a box collider. Also I need a rigid body 2D component to this with a gravity scale of 1. Yeah, that's okay now. Now the missile is created, and we need to store it in our prefabs folder. So a missile in our prefabs folder, and we'll delete this missile now. Now from the missile spawn point we have to assign this prefab to our missile. Now when I hit play, as soon as I click on the screen, from this spawn point this missile should be instantiating. Now if I hit play, you can see that as soon as I'll click, the missile will instantiate, and I'll clicking now, and you can see the missile is instantiating and falling down. Now we need to create a missile script that will make it destroy as soon as it is hitting anything. So let's make it. I'll go to the scripts folder and right click, create a C# script and name it missile src, and open it on Visual Studio. So now this is the missile script, and I'm going to remove these two tags, also remove these two functions. Now instead of these two, I'm going to add a void on collision enter 2D function, and if this missile is going to collide with anything, then it should destroy now this dot game object. Now I want to add one more thing in this missile, that at the time of instantiation, the direction of the plane and the direction of the missile should be same. So we'll go to the missile spawn script, and we'll spawn this missile as a game object, and we'll create a new game object variable named as missile obj, and we are going to assign this missile obj, this game object that is being spawned, that is the missile. And now the sprite renderer missile obj dot get component, the sprite renderer of this missile should be caught, or sprite renderer, yes, and the flip x of this component should be equal to the flip x of the component of the plane. Now this script is stored as a child of the plane, so we need the parent of this script. So transform dot parent. Now this will catch the parent of the script, that is the plane main game object, and now we want to get its sprite renderer component. So get component sprite renderer, and then we are going to get the flip x component. So the flip x component of the missile sprite renderer is equal to the flip x component of the plane sprite renderer when the missile is being instantiated. Now I'm going back to Unity, saving these two scripts and going back to Unity and looking if it's working or not. So if I hit play now, you can see that the missiles are spawning, and when it is colliding with anything they are destroying, and also the direction of these missiles are the same as that the direction of the plane at the time of instantiation. Now I want that this missile should only destroy when it is hitting with land or it is hitting with truck, not with anything else. So we need to change our missile script. Before changing the script, let me add tags to both our truck and land. So for the truck, I am going to add a truck tag. I'll name test truck. Save this and go back to our truck game object and give it the truck tag. And then I'm going to my land game object and I'm going to add another tag, that is the land tag. Save this and going back to the game object and assigning it the land tag. Now in the missile script I'm going to create two if statements. Firstly, if collision dot collider dot tag dot equals, if the tag of the collider equals truck, that means we are hitting the truck, then we should destroy this game object. Else if we are hitting the land, that means the collision dot collider dot tag dot equals the tag of our land, that is the land tag, and then also we want our game object to be destroyed. Destroy this dot game object. Now I have created two if statements instead of one, because if we are hitting the truck, then we are going to increment the score by 1, and if we are hitting the land, then we are resetting the score to 0. So these two conditions are showing different functionality later on, so we are going to add this functionality later. Till now it's fine for our script.
All you need is a laptop, a Wi-Fi and a dream. Thanks for watching today's video. All the assets and the script used in this video are on my How to Game Dev blog. The link is on the description down there. If you like this video, consider subscribing and hitting the like button. Make sure to share it with all your game dev friends, and feel free to comment your views, opinions and queries down on the comment section. Till then, dream big, hustle hard and keep watching How to Game Dev.